Now, our topic for today is on concept of electricity. And don't forget, in our previous topic, we dealt with static electricity, where I said we have two major types of electricity. We have static one, the one that doesn't move from one point to another in a conductor. Then we have current one, the one that moves from one point to another in a conductor. And inshallah, today we are going to base it on electric current, that is one that moves from one point to another in a conductor, under which we are going to study electric circuit, then component of electric circuit, type of electric circuit, then resistance in electric circuit. Now, when we say electric circuit, we mean the part provided for the flow of electricity. That is, the part through which current electricity flows. Now, we have a component of electricity. When we say component, we mean what are the things we need in order to form electric circuit. Don't forget, the first thing we need is what? The source of voltage, that is the battery. So we have it like this. This is a battery. Don't forget, and this battery comprises of many cells. This is the symbol. We have this symbol for battery. So by the time you now combine different cells together, it will form what? Battery. Therefore, this is the symbol for battery. So we have it like this. This is cell, this one is battery. So we have another component called voltmeter. This is voltmeter. We use it to measure what? To measure the voltage in the circuit. Therefore, I can easily use it to measure the voltage in this battery. What I just need to do, make sure you connect positive terminal of the voltmeter to the what? That of positive terminal of the battery, then negative to negative. So you can see, you have it like this. Here, you can see this one is giving us 1.4. Because it has been used. If it is what? Newly bought one, it will be what? 1.5. That is voltage inside. But now it's giving us 1.4 volts. Now, we still have another component. The symbol for this one, voltmeter in the circuit, is like this. This symbol for voltmeter, we have it V inside. Then we have another one, we have ammeter. Ammeter also looks like that of voltmeter, you can see. But the difference is that we have A inside instead of V. So its own symbol is like this, A inside in the circuit. If you see something like this, it means what? Ammeter. This is ammeter, this is voltmeter. So then we have another component called galvanometer. The function of galvanometer is to detect what direction of current flows. So you can see it has G instead of V or A. So it's what? G. You have two terminals as well. Then another component of circuit is resistor. We have resistor in the circuit. You can see we have different types of resistor. If the value of a resistance in the circuit is known, we call it what? Standard resistor. We have a resistor like this, and the value is written there. Like this one is 1 ohm. Don't forget, the unit of resistance is ohm. This one is 1 ohm, so we call it what? Standard resistor. It can come in this form or this form. They are both what? Standard resistors. Now, then we have variable one. One of the variable resistor in the circuit is that of resistant box. We have this. So this one, because we call it resistant box because it comprises of many resistors. So you can see it with number. We have 1 here. If I need 1 ohm resistance in the circuit, I will just remove this. It means I've created 1 ohm resistance in the circuit. If I need 2, I will remove this 2 and return this 1. So if I need 3, I will remove the 1 and 2, and so on and so forth. So we still have another type. So we have this one, we call it what? Rheostat. The function of this one is to vary the what? The current in the circuit. So when you increase this, you are increasing the what? The resistance in the circuit. So we call it rheostat. Now, we still have another type, another component. This one is called, don't forget, the symbol for rheostat is like this. Very simple. This one is resistor. This is a resistor. But when we have it like this, with arrow on it, we call it rheostat. So we still have another symbol, like I said, this one, we call it key, just to what? Open and close the circuit. As it is like this place is open, current cannot flow. If I want current to flow in the circuit where I have this key, I have to plug it. That's why we call this type of key, we call it what? Plug key. We have another type of key, we call it what? Tap key. So the symbol for that is this. This is plug key. Then that of tap key, like this. So these are the sums of what? Components in the circuit. Then we have type of circuit. We have three major types of circuit. We have open circuit, that is when the key is not closed. Then we have closed circuit. Then we have short circuit. For open one, it means if I have my battery like this, then I have bulb like this, and I have key. If this key is open like this, we call it open circuit. But if I close it, it becomes closed circuit. In that case, this bulb will glow. It will bring out what? Light. So therefore, this one is called closed circuit because the key is closed. Then we have open circuit when this one is what? Open. Open it like this. Then this one will not bring out what? Light. Then the third one is short circuit. That is, if there is no external load. Bulb is an external load. Even if we have fan, anything that will consume voltage in the circuit, we call it what? Load. So if you now have battery, and I just connect it like this, if I close it like this, we call it short circuit, because this cell is not delivering voltage to any external load. So we call it what? Short circuit. So those are the three major types of circuit we have. Now let's go to resistor. Like I said, resistor resists the flow of current in the circuit, and it's mentioned in what? O. Then what are the factors that can affect the resistance of a conductor? We have like, let's say we have this one. This is a resistor. As it is, what are the factors that can affect is what? Resistance. The first one is temperature. Number one, we have temperature. That is, how does temperature affect resistance of a conductor? When you increase the temperature, you are increasing the what? Resistance of a conductor. Therefore, resistance vary directly. Direct. Then another factor is, I remember there's one white question, I think 2014, that they said they drew something like this to form a circuit. They now said, if there's increase in temperature, how will it affect this bulb? So if you increase the temperature, you are increasing the what? The resistance in the circuit. Automatically there is what? Reduction in the brightness of the bulb. So another factor is cross-sectional area. Cross-sectional area. Then this one vary inversely. Then another factor is length of the conductor. So this one vary directly. Then the fourth factor is nature of that material. Nature of that material. So nature of material also affects it. Another name for nature of material is resistivity. That's where we are going. Resistivity. So let's use it to form an equation that we normally use in calculation. The factors. Therefore, resistance of a conductor R vary directly with length and inversely with cross-sectional area. So and don't forget, when you remove this one, we are going to put equal to and constant. Therefore, resistance is equal to constant L and A, where this constant is called resistivity. When you make it the subject of formula, it means resistivity is equal to Ra over L. So what will now be the unit of resistivity? Unit of resistance is ohm. Unit of area, meter squared. Unit of length, meter. This cancel this. Therefore, unit of resistivity is ohm meter. Ohm meter. Then opposite of resistivity. So therefore, resistivity is what? Opposition to the flow, ability of material to oppose the flow of current. Then it means it can also be defined as what? Resistance of cross section unit area, unit cross sectional area per unit length. Therefore, the opposite of resistivity is conductivity, that is ability of material to allow current to flow, and that one can easily be derived, since we know it's what? Inverse, it's opposite to it. If conductivity is equal to this and resistivity is what? We got 1 over, if this is conductivity, opposite of resistivity, it means what? This. So therefore they vary inversely. So as we all know that our conductivity is Ra over L. Therefore resistivity, our resistivity is equal to Ra over L. Conductivity will not be what? Inverse of this. That is L over Ra. Its own unit will not be what? Ohm, meter, everything is per minute. Or you say per ohm, per meter, anyone. So conductivity is inverse of resistivity. This is resistivity, which is Ra over L. Conductivity will be L over Ra. So the next topic will be on arrangement of resistor and cell in a circuit.